We'll give it a minute and then we'll get going. Hello, always. Did everyone enjoy the meeting yesterday with Dr. Neil Barrett? I thought it was quite informative, especially around like sort of what the cells look like. That could give you some hints and tips around, what to augment your data to look like. Okay. Just give it another minute. Let everyone get in. Okay. I see, Oasis, you've been quite busy with the team meetings and whatnot. Let me just bring up the participants there. How have the team meetings been going so far?
Hi, Rich. So yeah, we held a meeting last week and we performed some pre-processing steps on the images, and then we performed image augmentation on the images. And after that, we discussed a few things that we could try after we are done with training a base model.
Sorry, Oasis, I accidentally muted you.
Yeah, it's
Go
okay.
on.
Yeah, it has been a busy week, and
Cool.
I'm glad that everyone in at least in our team are contributing in one way or another.
Yeah, that's good. That's good. Have you delegated any tasks out to like people to do certain parts of the process at the moment?
So I was thinking that um, as as far as we are working with the images, so I think most of the people in our team are not very familiar with working with images, and
Yeah,
so I was thinking that once we extract the features into a tabular dataset, then I will share that tabular dataset with everyone, and after that it will be like a normal
yeah.
machine. Yeah, so then everyone can try feature selection and different type of techniques on it.
That's
Uh,
great.
yeah, for now I have been I have been coding, and I share everything with the team and explain everything during the meeting.
Perfect. Yeah. Salman is doing a session tomorrow at some point. He was going to do it today, but something come up, so he'll be sending out invites, and I'm sure. I believe he's going to do some like an introduction session to data augmentation and things like that. So it might help the beginners anyway, on top of the stuff that you're doing. So yeah, I'll give him a shout later and make sure them invites have been sent out. They'll be sent out from the Omdena Liverpool thing, because we both share that, so we can set meetings and record them very easily and whatnot. So that's great. Okay, so a couple more people have joined, and I'll just repeat what I've just said, just in case no one caught it. But Salman is going to host a session tomorrow, and it will more than likely be around data augmentation and image processing. It'll give especially beginners a good insight on how to get started, what kind of methods are used, and pretty much the easiest way to implement it. I believe as well, because Salman is a certified TensorFlow developer, he'll probably be using in-house packages within the TensorFlow and Keras mainframe. So it'll be quite an interesting one as well. I use TensorFlow quite a lot. I just haven't done the exam. I'm quite lazy. I just use it, and I just tell people I can use it. I haven't got the qualification yet. I haven't got the time. But yeah, it'll be definitely worth turning up to. So yeah, that'll be tomorrow. We've got 14 in now. Always, do you want to share some of the work that you've done this week, just with the team?
Yeah.
Cool.
Let me share my screen. Um, you guys should be seeing my screen right now.
Yep, we can see it.
Okay. Let me just move this. Uh, so this this is what we have done during the previous meeting. I will quickly go over the notebook. So during the first few blocks, we are just moving files around in the folders. Like I have if you have noticed inside the CNMC leukemia folder, there were three separate folders: fold 0, fold 1, and fold 2, and each one of them had separate folders for all and hem images. So I just collected all these images from these separate folders, and I stored them. Uh, I store all of them combined in a single folder. So one folder is for all images, and one folder is for him images. Um, so yeah, here I'm just moving the images to the folders, and after that, um, I w- I just visualize the imbalance that our that the more than half of sorry. So around 7,500 images are from the all class, and 3,500 around 3,500 images, 3,400 images are from the hem class. So it's just a way of showing that our data set is highly imbalanced, and this is something that causes very trouble while we are training the model. So then to deal with that, we perform data augmentation on the him images only. So after doing some data augmentation, and for data augmentation, we use the Curious built-in image data generator package. And we perform different type of augmentation on it. We like rotation range with width, shift range, and height range, and flip the images, etc. I'm pretty sure most of you will be familiar with this. So after doing the augmentation, I just recheck for the all and him images ratio, and so the imbalance is now there is no imbalance in both the classes now. So after that, I loaded the him images and all images into array, and then after that we performed cropping on it. So these are the images before cropping, and then these are the images after cropping. Uh, so yeah, this is all that we did during the first day, and for our Monday's meeting, I have prepared this notebook. Uh, so I will again quickly go over it. So after cropping the images, next thing that we were planning to do is to perform transfer learning on the images and extract features from it. So uh, yeah, that is what I have done here. I will not explain everything right now because
Yeah,
um, yeah, it's not properly presented right now. Everything is mixed up. I haven't cleaned it. So yeah, I performed transfer learning on it and extracted features from it in a tabular data frame. And this is something that I will be explaining in detail on Monday during our second meeting. So yeah.
that's cool. That's really good work so
And
far.
yeah, and after this we will train a classification model on it, and that will be our base model. So we will get some scores from it. It could be good, it could be worse.
Yeah,
And after that we will try different type of techniques on how to improve the performance or perform the scores.
very good, very good. What model are you going to use to set a baseline?
For the transfer learning or for the
For the model that'll be the classifier on the feature extraction.
so right now I'm thinking of a random forest, obviously, and I'm also thinking about SVM, but I think a random forest will be the good choice for
Yeah,
uh,
definitely.
yeah. But
No,
this
I
is
agree with
it's
that.
something that we will be experimenting on. We have a lot of time, so we
Yeah,
will be experimenting a lot of stuff.
yeah, and I think having treating it as a traditional sort of machine learning task as well by using traditional classifiers. You've got a lot of options, random forests, SVMs, gradient boosted forests, but you can also try stacking some as well. So that might be an interesting experiment just to see if you can push any performance out of it. And I would certainly look into using something like Optuna to find your hyperparameters. Of course, as its beginners, show them how to do it manually. So your grid search and your random search, cross validation and whatnot. But I think using something like Optuna is really good. I find it. I used it recently for the time series Kaggle project. I shared the notebook, and like the last couple of cells is about Optuna. Really easy to set up, and it runs a lot of different experiments as well. And I think I used it on a XG boost because what I did. I mean, I know XG boost isn't a time series; it can't like predict into the future. But I was treating it as a classification problem. Sorry, not a classification, a regression problem by creating lags basically, and it seemed to really help rather than doing the tuning myself and manually. It was because grid search and random search, they can be quite computationally heavy, but it seems Optuna have really improved that process, and it ran a lot quicker. So yeah, definitely take a look at that once you get to that point. It'll really help, and it'll be a good a good introduction to Optuna to the beginners as well. The documentation on Optuna isn't too great, to be honest with you. I haven't read it for a while though, so it might have been updated with the new releases. But I've used it a good few times, and I just do it, off the top of my head now. So yeah, it's definitely one to consider. Yeah, that's great work. Always. You got a meeting on Monday, did you say? Is that correct? I think it was Monday, wasn't it? But that's fine. Everyone who's joined since, has anyone got anything they'd like to share at all? Any experiments they've done, any research that they've done? I know there was the call on Friday was quite useful, and it contained quite a lot of decent insight. So I was just wondering if anyone's done anything since then. If you weren't able to attend, it's on YouTube now as well. Definitely worth watching. There was some good insights around the sort of biological aspect of the cells, what they look like. I want to say topological, but I don't think that's the right way to describe it. But there was certain clinical and physical differences between the two cells, whether they were positive or negative as well, which could be explored. Always has shared a previous notebook, which basically show like changing the cell's contrast may reveal some topological features that could be useful to a model. Always go ahead.
Um, Sorry to cut you off. I was talking to you and then my internet cut off.
Oh, okay. Go on.
Yeah, so I just wanted to let you know.
Cool.
Yeah. So,
That's all right.
Rich, you were talking about Optuna, I guess.
Yeah,
Uh,
Optuna. Yeah, I shared a notebook in there, and it's basically an automatic hyperparameter tuner, and you can set up various different experiments. And it is really fast, to be honest. When I've used it to compare to like grid search or random search, they can take a while. Especially if you've got, if you're looking in a quite a large sort of hyperparameter space, where Optuna does it quite quickly, and it gives you a nice output. You can track your experiments on it, and it's easy. Once you've pulled them, the best hyperparameters for your particular model, it's easy to implement them then in the next sort of iteration of it. As I said, I shared a notebook. Take a look at that. I think it's like the last. I mean, I was using it on a time series, but you can, I think the last quarter, maybe the last 5 cells or something, is where I implement Optuna. You can just literally copy and paste it from there and just make a couple of amendments to suit your purpose. It is really good. It might be worth looking into. I would suggest, though, using grid search and random search just for the benefit of the beginners, just to show them how to set them up and how it works and whatnot. But in terms of hunting down extra performance from your model, seriously consider using Optuna. It is great. I couldn't recommend it more.
yeah. So, I have heard about Optuna. I have heard the word Optuna, but I have never tried it on my own.
Let me
So,
just see if I've got the notebook at hand here, and I'll share my screen. Because I work for Capgemini, so it was like an internal Kaggle competition that was run, and I was the team lead. And it basically was let me just see if this is the notebook. Yeah. So it basically was a time series problem, but I turned it into a regression problem and used XGBoost, and it worked really well. So let me just, and that was done by creating lag features. So let me just share my screen and I'll show you what I mean.
Rich, you are muted.
How did I get around that? So select microphone. Let me just.
Yeah, you are audible now.
Audible now. So let me just share my screen again and see if that works. Let me just have a look in the audio settings. That's fine. That's so annoying. I'll tell you what I'll do. Let me just turn my camera off. I'll share the notebook on this screen instead. Give me 1 second. Always have a backup plan. That's what it's all about. Let me just load up that notebook. I don't know why it does that. It's really annoying. Okay, so open. So it's that notebook here. And I'll share my screen. Where are we? Okay, share. Just give it a sec to load. There we go. So this is, you don't have to pay. I shared this into the knowledge sharing forum. This is just part of the project that I've done within Capgemini. It was like an internal Kaggle competition, hence Capgle. So this is Omdena, and what I've basically done here is created a function which takes the trial. Now the trial, you set the parameters of whatever model you're using. So you can look in the documentation of the particular model to get this sort of information. And what I've done is the trial and used the suggested integer, and it's gone with the n estimators, and we want to look, search the space between 100 and 500. So you just, there's some of them like the verbosity and stuff and random state, you set them as whatever you know, so you can, the same experiments get the same kind of numbers and whatnot. But as you can see, I've just basically suggested floats here, call sample by tree, and set it for the minimum and the maximum value Omdena is going to search within. The model is the, oh, this was LGB, actually, I've done it with XGBoost as well, sorry, this is with the LGBM regressor. And it takes the argument in the params, it takes the params, and you just put your X train, your X validation in, your Y train, your Y validation, fit it, just as normal, use your normal prediction. This part here, I made a custom valid evaluation metric, SMAPE, but so you can get rid of that. You don't need that. And if SMAPE enabled as well, they were just some experiments we did as a team. But that is pretty much your setup. It's really quite easy to set it up. It's just like running any other model, but you just have to map out where you want Omdena to look within the hyperparameter space. And then this is the implementation study, and it's Omdena create a study. The direction is minimize, because you want to minimize your metric. And we were doing a regressor, and the SMAPE we wanted it to be as low as possible. So that's why we used the minimize part there. And the study name, you just set that, it was just called a regressor. You could set that as like experiment 1, experiment 2, or whatever. And then you start kick it off with the .optimize. The Omdena objective is the function above, how many trials you want. I just set it to 30, and you can show the progress bar true or false, and it gives you the, you know, it goes through the trials. The best trial in this case was number 11. So it was this one here, and it gives you, this was the lowest SMAPE, it was 1.101. And the parameters to achieve that are all there as well. So you take a look at the best value. That's what it was there, by just using best value. The study, the best params, and there's your params there. So you can just copy and paste them then into another params dictionary and set your model to take them params as well. And then you can use that to predict on your normal data. And that is pretty much it, really. It comes with the feature importance as well. This bad predictions, I'd ignore that as well. That was just something to do to optimize the time series, because there was a couple of periods of time where there wasn't enough data collected. So of course, the model was going to predict badly on them. And what I basically do there is get rid of the bad data. So you can ignore that. I think it's just this bit you need, really, is the Omdena experiment, and then these parts here just to explore the best parameters, and then use them best parameters to make a prediction. And of course, you've got your feature importance as well, which might be something to look at as well. Even though we're extracting the features, it might be interesting to see what features are actually playing a part within the prediction. I know that we won't have the names of them, but you know, it might be, because there's what was it always? There was like 4,000 odd columns, wasn't there? In when you just, it might be even an idea based on that, use feature importance and try and reduce that dimensionality. Even it's just, you know, it could be something that we can look at. But that's pretty much what Omdena does and how it looks as well. So it's not that difficult to implement at all, and it is quite robust. I would experiment with the, you know, the get rid of all that. And but depending on what you use, this is the LGBM regressor. They're going to be different for XGBoost. They're going to be different for random forest and SVM and whatnot. But I think it would give it an opportunity once you've got a model down and you've got your baseline. Then you can start working to fine tune it, and I think it might take a lot of the work away because it is really easy to set up. I'll share this again in the channel, in the knowledge sharing channel, only because it might have been lost in all the chats that have gone on there at the moment, and it'll be a pain in the backside to scroll back. But yeah, it's pretty simple. The Optuna website has plenty of documentation as well. It's just really powerful, really saves time. As I say, this probably took maybe 15, 20 minutes to run. And if you were to do the same thing with random search or grid search using the sort of hyperparameters, the amount of hyperparameters and the sort of space that they were searching in, it can take hours, especially in Google Colab as well, if you haven't got like any sort of pro account where you get the better CPUs and the better GPUs. But yeah, it's worth thinking about. As I say, I'll share that again. Very easy to implement, but very powerful at the same time. I don't know whether it can be used with neural networks. I've never used it before for a neural network. I haven't needed to. I'm going to have a look right now, in fact, for convolutional neural networks. I'll put because it's very neural networks. Let's have a look. Yeah, it's got people using it for PyTorch implementations of convolutional neural networks. I imagine with very minimal code changes that could be done with TensorFlow. There probably is already TensorFlow implementations of it out there. Take a look at that. It's something I never knew. I've never used it for CNN. So yeah, if you're in team 2, definitely write that one down. It'll be interesting to see the implementation for that. I imagine it'll be very easy. Yeah, very, very similar to HyperOpt as well. Yeah. I mean, it's a lot, if you're working on traditional sort of, ML classification or regression problems, AutoML is really good. Using PyCarray, H2O, I've used them before and they're fantastic. They tune the hyperparameters for you and they choose the best models as well. A lot of it though was used in especially on Google Cloud. Vertex AI is very powerful. And a lot of the time, if you're in industry and it's, let me think of an example. A lot of the time, industry doesn't necessarily need you to build a model from scratch. A lot of the tools that the cloud services offer, AutoML in AWS, the Vertex AI in Google Cloud and whatnot, for a lot of companies, they're sufficient to if they're doing things like clustering, to try and manage the customer base, they're trying to predict sales or whatever it is. A lot of the time, AutoML has the answers to that. Yep, Azure AutoML is very good. When you need to build custom models is usually when AutoML may not appreciate domain knowledge. So, you can add features to feature stores that the AutoML uses, and it can sort of reflect the domain knowledge that your team has. But a lot of the time, it might be a bit more difficult trying to explain how AutoML works in regards to that domain knowledge. Having a couple of features that your team have worked on and putting them in a feature store and having AutoML use them and make predictions. It doesn't, it's still a bit of a black box, but if you make a model from scratch, you know exactly what's happening and you can explain it to your stakeholders a lot better as well. That is the only sort of downside I've seen with AutoML, but a lot of companies who have, use AWS and whatnot and are using machine learning, they do for the smaller tasks and the simpler sort of tasks, they definitely use AutoML because it's on them sort of problems. It's hard to beat. It's only when your tasks become a lot more complex is when you start to build custom models. If you're pulling in data from numerous different, different sources, where feature engineering is very, there's a lot of domain knowledge injected into them features, which may not be appreciated by a AutoML model. That's where good old-fashioned building it from scratch comes in. Still very important, and still very, I don't think AutoML will take over it completely. It's just not, but then saying that again, I wouldn't have thought chat GTB would be so good. You know what I mean? It might change in the future, but especially around medical things as well, it has to be really, really precise. And the best people to get that sort of knowledge from is obviously human people who work in the particular industry. I don't think AutoML would ever get as good as their inherent knowledge, but I wouldn't quote me on that as a fact. I probably will be proven wrong, but at the moment that is certainly not the case. So it's just one to think about if you want to use AutoML just as a side experiment. It is a little bit harder to explain. They do come with things like SHAP analysis and all that kind of stuff, but I think explainability is a lot easier if you're in tune with what you've put into the model and you understand what you've put into the model more than any artificial intelligence could derive from it. That probably will change in the future, and I'll sound like a old man who is completely out of touch. So I imagine it will go that way. But yeah, it's one to think about. If someone wants to try AutoML for this particular problem, please do. It'll be fascinating to see the results, and we can compare it to our models from scratch and whatnot. But yeah, if in team 2 especially, Omdena optimization for the PyTorch implementation or the TensorFlow implementation, definitely an avenue worth exploring. I've never done it before, so it'd be new to me as well. I've only used Omdena with traditional tabular kind of problems. So yeah, it'd be interesting to see that. Come back and teach me something about it. Other than that, though, I think that is probably about it. Unless anyone has any questions, has anyone got anything they'd like to share? We've got about 7 minutes left of this meeting. Oasis has done fantastic work. Oh, sorry, go on.
Sorry, Rich. I did a few things, like basic things, and I had I just put the raw data into a CNN model and try to see how it is working on it. So
Yeah.
maybe I'll share my thing if it's fine.
Yep, go ahead, please.
So, yeah. So what I tried here is, yep. So I did a basic augmentation and the pre-processing, like the resizing of the image, and I took one of the code from the OS code to like to augment it and to do the pre-processing of this. Like the contrasting of the image. That's what I did. That's what I did. And then I just put on I just used the basic modeling and put all those things into a CNN model to see how it is performing. And what I noticed was the CNN model was kind of not performed at all. Like it was kind of overfitting on the it was doing better job on the training set, but not on the validation one. So this is what I have done. And also I tried few more things. I'll show it here. So I tried to from the last meeting with the Dr. Neil. So I tried to crop the data, just to have the image, the cell image only. So I tried that and try to augment, try to see what we can do here to process it better. So I tried with a few of the things with the um, histogram equalization. I tried to experiment with the clip limit. So with that, I tried to see how they are performing. So this is what I have done basically in this one.
That's cool. I think, you know what, I think those, from what the Dr. Barrett said, I think the contrast and histogram is probably a good idea to experiment with, because look at the original images and then look at them with the various different styles on. You can see a lot more detail, and one of the points that the doctor made was the fact that there is like one of the ways they validate these cells of being positive or negative is the what do they call it, the vascules or something like that within the cell appear to be they appear to be like lumpy in a way, and they have this contrast and white space in them. So I think that really may help on both projects, not only the vision alone but also the feature extraction as well, because that would generate a more precise feature from the high contrast to the low contrast. Definitely worth experimenting with, because you can see it right there. It is quite profound.
Right. Yep. And also like with the CNN model, I try to see like how they're like, I was mostly doing the hands-on learning thing. So I was trying to see like how each layer are processing the data and what they are basically learning from. So this is what I have done on the feature map from each layer of the CNN model.
Yeah, that's really good. I think that's going to be quite a key as well to explain how a convolutional neural network works to a beginner. Would you be okay just typing some notes around that and what is being observed there and why it's important to observe this, just so you can share that notebook again and have it quite well documented so people can use it for reference? That's a great idea.
Sure. I can share the notebook. Yeah, I can do that.
That'll be perfect. Yeah. Because I think a lot of the time when you're building projects, people who've used convolutional neural networks before take this sort of stuff for granted. But the fact that you've split it down on each layer and seen what it's learning from, that's really good. And if you just document it a bit more, add some notes explaining what you've done and why you've done it and what you're actually looking at and why this is important, I think that'd be fantastic to share to beginners. Really good work.
Sure, Rich, because like it is also my first image, like working on the image one. So I'm trying to learn with the wherever I can find them. Yeah.
No, that's great. That's great. Yeah, if you could do that, that'll really help people, I think. Definitely. Yeah. But these images that you've put through, are they did you put the raw images through this example here?
Oh, yep. This is the raw image.
So it's curious that it's seeing some of the feature maps, but in some of the cells, it doesn't look like it's picking up anything at all. So it would be interesting to do it again with the high contrast images and see if there's any difference. Because if, from the way it looks, it's not picking up information from some of the cell images. Do you know what I mean? So it might be interesting to experiment to see if the high contrast makes any difference whatsoever.
Sure. Yeah, that's another one reason like why I tried to crop the image and then contrast it. So that's one reason why I did that, like why I did this part.
Yeah, that's really good. That's cool.
So
yeah,
I'll have a look on that. Yeah, and share my image, like the
perfect. Well, thanks very much for sharing that. Yeah, add a few more notes to it and get it to the knowledge sharing group. I think it'll be really beneficial. But the cropping as well are very important. I like what you've done with the cropping. You've pretty much done it to the border. We're not losing any information at all, but the sort of black space around it is going to be pretty much redundant for the model, and it's just going to increase computational time and things like that. So yeah, that is definitely a way to go for sure. Spot on.
Yep.
Thank you very much.
Thank you.
Has anyone got any questions? We've got 30 seconds left. No? Okay, well, thanks everyone for coming. Thank you, Oasis and Varun, for sharing that work. That's really, really good. We're making good progress. I'll catch up. Hopefully team 2 are in the same positions as team 1. I'll catch up with Pranjal at a later time. I know I think he mentioned he can't make all the meetings and things, but that's fine. He's got a team meeting set up, I believe. But yeah, thanks everyone for coming, and I'll see you soon. Have a great weekend, and I'll catch you on